should probably scooch my chair up.
All right, so I'm going to wait until it pings 5 here, and then we'll start right at 5. All right, so I'm seeing you. All right, so I'm going to start it now because it's... All right, so good evening or afternoon, everyone. Welcome to Astronomy at the Beach. This is our teacher forum, and we have 2 panelists here. We have Connie Martin-Trembley. She is an award-winning middle school science teacher at Endeavor School in New Haven, Michigan. She's a member of the Warren Astronomical Society and has a passion for science and astronomy and is teaching an astronomy class online this year. She is a volunteer at NASA JPL Solar System Ambassador, and she has an asteroid named after herself. Paulette Epstein is a space science expert and serves as the Director of Science Partnerships, Theaters Manager, and is resident astrophysicist for the Michigan Science Center. In this role, she creates STEM-related programming using innovative technology and fosters scientific partnerships for the institution. Paulette is spokesperson for the Michigan Science Center and is also a volunteer NASA JPL Solar System Ambassador. I'm Bob Trembley. I am the Outreach Officer for the Warren Astronomical Society. I am also a volunteer NASA JPL Solar System Ambassador. I'll be acting as the moderator for this, and I'll be monitoring the chats on YouTube and Zoom here and passing questions off to our panelists. And with that, I'm going to mute myself and let these 2 women go.
Okay, who wants to start?
Go ahead.
Go ahead. Okay. Like Bob said, I teach middle school, 7th and 8th grade science, and 8th grade is where the astronomy portion of the science comes into the middle school program. So how do you get kids interested in doing astronomy? And some of their perceptions I find are very interesting perceptions. And so I know that Bob and I have had some of the discussions of some of the things that my kids say and some of their perceptions of, well, how did that happen? Or what they think we've done and where we've gone. I don't know, Paulette, do you find the same thing with the kids?
Absolutely.
Or with the people you do?
Yes. Yes, I find that especially when we're talking about other star systems, they say, oh, when have we been there? And it's like, oh, no, not yet. But next generation might be able to get there. So at the Michigan Science Center, we are really just trying to inspire that next generation to be interested in science. So we don't necessarily... I mean, we do care. We do want them to become scientists someday, but we also want them to be scientifically literate. And so that's one of the things that we try to do here at the Science Center. The nice thing about astronomy is that it's interesting for a wider audience. And so we find that if we can get the parents involved and the parents interested, if we can get the kids interested in astronomy, they're much more interested in some of the other sciences as well.
Exactly. And to me, everything is science, like Bob said. I teach it, but we pretty much live, eat, and breathe it. It's just always been a passion in our life. So, you know, our poor children were dragged outside onto the stoop at like 4 a.m. to see the space shuttle go overhead, you know, that kind of thing. That is the way that our kids grew up. And what I found, my very first assignment for my astronomy class, Lord knows teaching this year is very, very different and looks very, very different. As was, my students had to look up. And I find most people don't look up. They look down, or they have their phones and they look down, but they don't look at the sky. And they don't, we of course had the terrible fires out west. And so their first assignment was to describe the sunset, because we were very hazed over by the smoke that had gone into the atmosphere. How did it change the sunsets for us? And so that was their first assignment. So part of what I'm trying to teach them to do right now is to look up. And that can be a challenge.
Yeah, and in the planetarium here at the Science Center, it's been really interesting because, you know, you have kids come in, they sit down, we turn off the lights, and they're like, I can't see in front of my face. Like, you don't need to see in front of your face. You just need to see above you. And then they look up and they go, whoa, and that's when we really hear it. But looking up is definitely something that we encourage people to do whenever we do any of our programming, including we've switched to virtual programming ourselves here. So we do virtual planetarium programs with our online audiences. And we've actually been encouraging them to go outside and look for the stuff that we talk about during the program. So we do talk about some of the bigger things, like we've gone to the edge of the universe and back, but we always want to bring it home to something that they can see or observe for themselves.
Yes, it's making that connection. Otherwise, they lose interest.
Yeah,
it's making those connections to themselves and trying to teach them as well that our own atmosphere is part of that astronomy. So, you know, whether they look for sundogs or whether they are looking at particular cloud formations. I'm sorry. Let me introduce Andromeda. This is Andromeda. And Andromeda has decided she needs to be part of this. She was being very upset that we were ignoring her. So you have to be quiet. So it's trying to teach them that astronomy isn't just about the stars, it's about everything that's out there. One of the more interesting questions, I have a huge map when we were talking about perspective. And as parents, how do you give perspective when maybe the parents themselves don't have the perspective? We have such great computer graphics now. And I have this massive map in my room that was taken by satellites. And one of my students, 8th graders, had asked me, this was a couple of years ago, he goes, well, where's the other Earth? And I had to stop. And I'm like, okay, could you say that again? Because I was trying to understand what he was talking about. We had been talking about exoplanets and the fact that there were planets outside of our own solar system. He goes, well, the other Earth, where's the other Earth? And I said, can you explain what you mean? Well, he pointed to the map. And from his perspective, we must have taken a picture of that while on the surface of our planet, looking up, and snapped a picture. So there obviously was another planet out there that looked like us. And these are the perceptions that I'm finding my students are coming in with. They think we as in humans have walked on Mars. And it's like, no, we've only been one other place, and that's a total of 12 people, and that's our moon. But we have pictures. So obviously somebody had to be there to take those pictures.
I love talking about the robots on Mars, because now that we're doing our virtual planetarium shows, we're actually able to do a lot more than we are in our traditional planetarium, and so we're able to fly down to the surface of Mars and check out Curiosity and check out Opportunity and and Spirit and all of the other rovers that have gone down to the surface, and so that's one of my favorite things to talk about, is that Mars is the only planet in our solar system inhabited entirely with robots.
Yep. And so it's trying to give them that perspective. Mars, humans have sent so many probes to Mars, whether as satellites orbiting Mars or the probes down to the surface to explore the surface of Mars. And, you know, like you say, it's totally inhabited by robots.
Yeah.
And understanding the concept of how long it takes to get somewhere. Their perception, and a lot of people's perception, my favorite saying for my students is, there is no planet B. this is it. But you see in the news, they said that there was an Earth-like planet. And that's
a while to get there.
that the time and distance are so difficult. They're such difficult concepts to understand. That distance, what we're talking about, you know, to get to this Earth-like planet that is however many light years away, that we don't travel at the speed of light. And what would it mean to get there? And if it's Earth-like, really, that doesn't necessarily mean that it's another planet just like ours. Exactly. So it doesn't necessarily mean that it's going to be hospitable to us. So it's their perception is one of, well, we can just go to this new planet they found. And it's like, no, we really can't. Yeah. And they don't understand, because what they've seen on the news or what they're missing that small science piece that explains that time and distance.
Yeah. So one of the really nice things about working here at the Science Center is I see all ages. So I see we start our planetarium shows at about 2 or 3 years old, and then we have planetarium shows that go all the way through adult. It's interesting to see that sort of progression between what they're learning and how they're learning when we're going through sort of the different ages. So, for example, kindergarten or the 3-year-old to about 1st grade, we sing Twinkle, Twinkle, Little Star. We tell stories about the constellations we see in the sky, our constellation friends. And then as we get older, we start to talk about more of the things you can see in the sky. Then we get to planets, then we get to the size of the solar system, the size of our galaxy, and we just kind of keep going. And so it's really cool to see a lot of our members that we have here at the Michigan Science Center just sort of go through that progression. And I think one other thing that I've noticed with sort of this sort of informal science education in general is that we can't underestimate these kids either. So some of them don't know, anything about the solar system, but I have had kindergartners come in and tell me every single planet in the solar system in order, what makes them special. They've corrected me during the show because I said something wrong.
Yeah.
And the weird thing about astronomy is it is constantly changing. So I was doing a show and I said, okay, so Jupiter has 79 moons. And the kid was like, no, it's 69. I was like, we just discovered 10 like 2 days ago. So yes, but no, we're finding more all the time. And then I've had, one of my most favorite stories from being here at the Michigan Science Center and being in the planetarium was I had a show that was actually our most advanced show. And I let them know that when they entered, but the kid was about 5 years old and had seen all of the other shows. So he wanted to come in and he wanted to see the most advanced one. But luckily it was just him and his mom. And so we were going through everything. And then I got to the point in the show where I normally talk about dark matter. So stuff we can't see, but we know that it's there. And trying to explain that to a kindergartner, I had to sort of flip my thinking a little bit. So definitely just stuff we can't see, we know it's there, but it's going to take the next generation of scientists to figure out. And I had, after that show, the kindergartner come up and tug on my shirt and say, I'm going to figure it out. And I was like, yes, you are.
You said you want to cry.
Yes.
Or I'll have students where they'll say, well, why haven't we gone back to the moon? And I'm like, but your generation will.
Exactly.
And maybe you'll be on a space station orbiting the moon. That will be that launch platform to Mars. I said, that's long gone for me. I said, but it's your generation coming up. And to hear them, and like you say, those that come in and they know everything. And so their fascination is there. and to continue to encourage that. And then when you tell them, NASA's always looking for astronauts, somehow they think a lot of kids are, well, you have to be when you say scientist, that's Albert Einstein. It's like, no, anybody can be a scientist. Anybody who has just a passion to learn about it.
Yeah,
and you tell them they can be that next astronaut.
Yeah, one of the great things about the Science Center is we have a project called the STEManista Project, which is for 4th through 8th grade girls. We specifically target Black girls, and we try to really reach them with science and careers in science, and really push that because they don't see themselves as scientists. We're finding that middle school girls though they are exceeding boys in math and science, they're better than the boys in math and science. They're getting less and less interested in it as they get older, and that's partially because of the society that we're in, and they think that, oh, well, that's not cool, so I'm not going to do it. And this is the girl that was very uncool in middle school. But
I will say, being a nerd has become the cool. I'm like, wow, I would have been cool all those years ago.
Yeah.
Being a nerd is now cool, which is nice to see, because I would have been cool way back in the day.
Yeah. So the nice thing about this program is that it really does, we pull people from the scientific community, engineers and scientists and astronauts, and they were actually able to see Mae Jemison talk in person, which was amazing. They even got to talk to her. And so we use role models to really encourage these girls to be able to continue on with their interest in science. And I really think, looking back at it, I was interested in astronomy and science pretty early. My father took me out for he dragged my butt outside. We set up pillows on the porch, and we watched, I think it was the Perseid meteor shower, and we saw a whistler. That was cool. And we would just go outside for every astronomical thing. And that's kind of what got me started in my love of science. And my parents really encouraged me to continue that love. My parents, my siblings, my sister beat up a boy because he was being mean to me because I was interested in science. It's been really supportive, and I'm really lucky to have that, and not a lot of kids do. So that's one of the things about teachers and about places like the Michigan Science Center, is we're here to be that support for our students as they get older.
Can I ask how old you were when you went out with the pillows to look at the meteor shower?
I was 4.
You were 4. Because my first experience was in a way similar. I was younger. I was probably in 4th grade. I was in Girl Scouts, and my mom was my leader. And she had our troop come at night to a field, and we all laid in the grass to look at the constellations. So our job was to find the constellation, to actually take the time to look up at the night sky and to try to find, of course, yes, we know that the Big Dipper itself isn't a full constellation, but to find the patterns in the sky. That began my love of science. And, parents, I think, play such a critical role in doing this. Like right now, the leaves are changing, taking the kids out to see the leaves change, to just that observation, taking them out during a meteor shower, that kind of thing. It forms your life. It does. It has a huge, huge impact. And like you say, not every child has that.
Yeah, and there's also a lot of children, like especially inner city kids in Detroit, that have actually never seen a nighttime sky where you can see the constellations. They see, so I live downtown, and I see the Summer Triangle, I see the Big Dipper, I see just a couple of different things. So I'm able to see the planets, but there are lots of kids that are unable to do that. And
that's because of light pollution.
Yes. So either taking them outside of the city or taking them to a planetarium is really important to sort of expose them to the nighttime sky. You can't take them outside of the city. Some people have transportation issues, and so planetarium definitely the way to go, getting them interested.
We have a question from the audience here. They'd like to know how you choose to teach the scientific method.
Wow. How I choose to teach the scientific method? Wow, what a question. The scientific method, when I teach the scientific method, generally I do it with the start of a lab, and we go through, what our purpose of a lab is. Why there's always a reason for doing something, and it's almost teaching them step by step. So I do it with a series of labs, and then generally by the time they get to me and I ask them what a hypothesis is, they can sing song it. It's your best educated guess. But then I break it down. Well, what does that mean? And then it's blank faces. So we discuss, how it's you making a guess, pulling in the information you already know to try to determine what's going to happen next. I think the biggest piece now is as they do their experiment, and it's also teaching them it's okay to have the wrong answer, because you learn things when you have the wrong answer. But then it's also retesting. It's also, that's that step that is a newer step. When I was growing up, it was like, okay, then you had your testing, you took your data, you then had your conclusion, your observations and your conclusion. But now there's that you don't get quite what you thought you were going to get, how do you redesign? Taking what you have, redesigning it and retesting it. So teaching them that it isn't a straight line. It's actually this cyclical thing of testing, observing, trying to come to some kind of conclusion based on your test, but then going back, redesigning, then retesting. So that's a newer piece. I'm not sure I answered the question, is if that's what they were asking.
So at an informal science institution, we do it a little bit differently than regular school, because the teachers teach them that in their classes, and we're not here to replace teachers. We're here to supplement learning. So we're here to give students a place to be able to see the things that they're talking about in school in action. So the way that we sort of talk about the scientific method here, especially with our exhibits, we use 3 different questions. We use, what do you notice? So we ask them what they notice about the thing that they see, the phenomenon that they see in the exhibits, or even in the planetarium. What can you try? So we have things with buttons. We have things like they try to shake it. Okay, that didn't work. We're going to try to stop the movement. Okay, that didn't work. So what can you try? And it's really interesting to see that they come up with things that the exhibits were totally not meant for. And that's okay. So it's what can you try, and what does this remind you of? So that gets back to the prior knowledge that Connie was talking about, where, what does this remind you of? What can you think of that does this? And then that sort of leads into the scientific method, where you're creating a hypothesis from that, and then you're able to try it. So what do you notice? You're creating your hypothesis. What can you try? You're testing it out, your lab. Basically, what does this remind you of, using your prior knowledge? And then, okay, what does this remind you of? Now, what can you try? So you can use those 3 questions in any order. And I think that's the thing about the scientific method that, at least when I was younger, wasn't really communicated very well, that the scientific method can start anywhere.
Yes, absolutely.
And so, you know, we think it's very linear, but it's actually pretty cyclical when you're actually getting down to it. And so those 3 questions, though we're not specifically using the vocabulary of the scientific method, we're still teaching the scientific method and getting it in their brains.
One of my favorite things is when my students ask me, you know, we'll be in a lab, well, what would happen if? And I love it. It's like, I don't know. Now that's the first thing that I try to teach my students. I don't know. I don't have all the answers. And a lot of times kids, I think are in a way, they come to us, especially middle, we're supposed to have all the answers. No, it's okay not to have all the answers. And it's like, I have no idea. How can you try that out? You know, and I love it. And so the lab will go in a totally different direction. But that is the key to that scientific method, is getting their interest and trying to answer a question or find out what would happen from something that they want to know or they want to learn about. And that can be done in so many ways. And like you say, it can start from any point.
And I think you saying, I don't know, it's super important, because that's, again, teachers and adults are supposed to have all of the answers, but we don't have all of the answers. We don't.
And their faces when you tell them, I don't know. And they look at you like, are you crazy? You're supposed to, no, I've never thought of it that way. And then they get excited because you never thought of it that way.
Yeah. And the other thing that I love about that is students tend to think that we know everything about science. We know everything already. So why do I need to go and study science? Well, because we don't know everything already. So I did research at Texas A&M with the cryogenic dark matter search, and I've done a couple of talks on that topic. And basically, it's an hour of me telling you different ways of I don't know. So like, I talk about what we did and how we did it and the methods that we used and what we were trying to do. But is it right? Mm-hmm.
And it goes back to what you were saying before, with science is the one discipline that changes on a daily basis.
Mm.
It is, I mean, don't turn around because there'll be something new, you know, like with Venus and finding the atmosphere of Venus, and you're like, okay, if you don't know what we're talking about, there was, now I'm trying to think of the name of it, Bob, what was it that was found in the atmosphere? Phosphines, and which is an indication of some kind of life form that's there. And this is all like within a week. Science changes day to day to day. So what we thought we knew yesterday or last year or 10 years ago can be very different today, because our technology is constantly changing and allowing us to do things that we haven't been able to do in the past.
And what I love about that finding is that phosphine is really is found mostly in penguin poop. So my imagination goes to there's little penguins living on the surface of Venus. Like, that's probably not what is actually happening. But you know, we talk about our imagination, and you lose it as you get older. You do, because you don't exercise it as much as when you're younger. But imagination is super important in the sciences. So important in the sciences, because you need to imagine that next thing that we might be able to find. So we might not think of it as imagination, but it is imagination. And again, little penguins.
We do. Well, I think because kids are taught to be structured as they go along. And so in science in particular, like you say, that imagination, thinking outside the box. I do an activity with my kids where they write their name in cursive, or I write their name in cursive for them because many of them don't do cursive. And you do it in pencil, you fold the paper in half and you rub the outside with the pencil. And when you open it, it looks like it looks like their name has created some kind of little creature, some kind of little bug. And then they have to, that is their alien. Now tell me where they live. And believe it or not, the 7th and 8th graders love to do this. It's like, what's their planet going to be like? They have to develop the whole thing. What's their atmosphere like? What are they living on in their planet? What are, and the whole thing is thinking outside that box. And that can be very hard to get the kids to do, because somehow they think, oh no, that's silly. I'm not allowed to be silly anymore. Like the little penguins on Venus. I'm not allowed to be silly anymore. And it's like, no, you really are allowed to be silly, because that silliness brings in so many things that in different ways of looking at things. So we're in, it's like the elementary works very hard to get their little ones to stop being silly. And in the middle school, we work very hard to try to get them to be silly again, within reason, but to be silly again. And to think of little penguins walking around on Venus, and to use that imagination, because somewhere along the line, they tend to lose that. And then they stop reaching beyond, oh, no, you can't do that. Yeah, you can. Go ahead and reach. How far can you reach?
I love being the silly example.
I love it.
Question for both of you. I know Connie's answer for this. I'm pretty sure Paulette has been asked this a billion times. Is there life in outer space?
You want to take it first? Or do you want me to?
I'll take it. I think Andromeda probably agrees with me. So statistically, yes. We know that there are about 600 billion galaxies out there. We've estimated about 600 billion galaxies out there. Each of them have millions, billions, or trillions of stars. Let's say they have billions of stars. And most of them have planets around them. So when you're talking about this from a statistical point of view, us being the only planet with life is crazy. Like, that's just not possible from a statistics point of view. Now, we've also talked about places like Enceladus and Venus. We're finding phosphine in the atmosphere, places that we might think that we can find life. Now, it might not be life like we understand life to be on the Earth, but it's probably there. And life can take on so many different forms. Does it need water? Maybe. Carbon-based life forms might probably need water, but what about other based life forms? What about other things that might be out there? Silicon-based life forms. Like, there is the possibility of having life out there that is totally different than what we would expect. There's life at the bottom of the ocean. The bottom of the ocean next to thermal vents. It's so hot next to those thermal vents. The pressure is so great, but there's life there. So when we're talking about those extreme environments, it makes me think that, that extreme environment is kind of similar to the extreme environment that we have on Venus. There's no water, but there's other things. There's sulfur in those vents, those thermal vents. So it's possible that some of that microbial life that we find at the bottom of the ocean might be similar to some of the microbial life that we might be able to find on Venus. So my answer is yes, there has to be life out there statistically. Have we found it yet? No. But we've also only been looking for it for a very, very, very small amount of time when we're talking about the universe on a grand scale. So if the universe is 13.8 billion years old, like, we've been searching for it for what, 20, 30 years? So it's a teeny tiny amount of time, and there's got to be life out there. Is it going to be like us? I don't know.
Now, my answer to this, and this is interesting because I just did pose this to my 8th grade students. We're just beginning the we begin with plate tectonics, basically the formation of the solar system, okay, and what our early solar system was like, and all this. And I posed a question to them, and which is so much fun because we were all on Zoom and all their little faces are up on the screen. And I said, do you believe in life in outer space? And some sat and they thought about it. Some were right away. Yep. Oh, yes. Yes, I know there has to be. And they came up with this thing that, there's so many other planets out there that we can't be the only ones. And some are like, nah, I don't think there would be other humans. I said, that's not what we said. Life can be a virus, right? Life can be, something small. And they all sat and they were discussing and they really got into it and they got arguing and they were comparing and they were debating it. And I just sat back and I finally said, okay, is there life in outer space? I said, where do you think you are? All of their faces were like, and I said, you tend to forget you're in outer space. Do I believe in life in outer? Absolutely, because we wouldn't exist if I didn't. I said, it happened once. If it happened once, what are the probabilities of it happening again? Not to the same, not human life, but life in some way. I said, so ladies and gentlemen, you are life in outer space. They had never looked at it that way. We don't. We tend to be very egocentric. We are, this is us. We're the best. This is, and it's like, and take one step out and you'll see that you are on this little blue-green ball floating in space, orbiting a star, along with other planets orbiting a star. You tend to forget that you do that. And several of them are like, I'm having trouble wrapping my brain around this. I'm laughing, saying, most people have trouble wrapping their brain around this. But that is the answer. The answer is yes, I do believe in life in outer space because I'm talking to you. And that's exactly where you are. So, which is the very simplistic answer, but it's one that people tend not to think about. Well, I live on Earth. Yes, but where's Earth? What is Earth? Where is Earth? What's it doing? And they tend to forget that they themselves are in outer space.
And I love that flip in perspective, because that's something that human beings are really terrible about, is like seeing things from another point of view. And that's why science is so great, because you kind of have to take yourself outside of what you are. You have to step back. You have to be non-biased, and you have to look at it from a scientific perspective. And like I said, we as human beings, and especially Americans, have a hard time doing that.
It was just absolutely priceless to see, because I see all their faces across my screen. And the moment I said that, as it started to click, their jaws started to drop. And I went, that was a teachable moment. That was a moment that I was able to give them a perspective that they themselves, I had never thought of it that way. It was a way of showing them you can think in a different way. So yes, I do believe in life in outer space. I do believe in life on other planets. Now, what kind of life I can't tell you, but I really would hate to think that we're it.
Yeah, I definitely agree.
Okay, you were both mentioning size and distance, and I know that Connie does a walking thing. Why don't you tell everybody what you do there?
Well, most of the posters you'll see of the solar system show the planets all lined up, and they do that. I know why they do that, because they're trying to give people the perspective of how the planets compare to each other in size. unfortunately, the unfortunate side effect of that is to tell people, or to in a way teach people that we're really close together. You know, that goes back to the, well, why don't we just go to Mars? Okay, where are we in our orbit? Where's Mars in its orbit? How long is it going to take us to get there? And then how long would it take you to return? We won't even discuss all the other problems there. So what I do is I walk the solar system with my students, and it's about a half mile using a ball, an 8-inch ball, as the sun. And I have everything on 3x5 cards. And of course, Mercury is the size of the head of a pin. And I said, no, we're going to bring the sizes way on down so we can understand them. And I tell them, you take, you know, the first, who wants to be Mercury? And they come out, and I'm like, okay, it's 9 paces, just walk normal, 9 paces, not foot to foot, but 9 normal strides, and then stop and turn around. And that's their first indication, because somehow they think Mars is almost, or I'm sorry, Mercury is almost like right inside the sun. And I'm like, no, if Mercury was the head of a pin and the sun is the size of an 8-inch ball here, they're not. They're actually quite far from the sun. And then the next one starts from that planet and paces back. What I love is when they get to Jupiter, because really the first 4, and we discuss how much sunlight are we getting? How much warmth are we getting from the sun? You know, that Goldilocks zone that we're in. And, you know, Mars is in that Goldilocks zone too, but it doesn't have a magnetic field to help it retain any kind of an atmosphere. So it's this barren planet. But then I have them walk to Jupiter, and I don't tell, I said, who wants Jupiter? And they come up, and I show them in the corner how many paces they have to take. And I think it's 95 from there. And they begin walking, and the kids are like, they're not stopping. Mrs. Trembley, tell them to stop. Mrs. Trembley, they're supposed to be stopping. They're still going. And all the kids around me are saying this, and I just stand there as they pace way away. And then when they stop and turn, we all wave, and we discuss the size of the sun and how far is this. And now we got their interest. Now the next one's, I want to be Saturn. And that's 112 paces away from Jupiter. And it's only like the size of an acorn. And it's like, so then they take off. And then some want to wait to be, you know, Uranus or Neptune. And we all walk Pluto. So I'll put the ball down. And as we pick all the other kids up, we turn to look at the size of that ball and to look how far we are and to discuss, you know, by the time you get to Jupiter, it's like, is it getting any sunlight? No, you can barely see it. It's pretty much a star in the night sky to Jupiter, and how Jupiter's actually producing more heat than it's taking in. And you move off to the next planet, and they're like, oh my God. I said, this is what we're talking about when we talk about distances. This is why we can't just hop on a spaceship and go to Mars. And this is why it took New Horizons 7 years to get to Pluto. And, you know, this is why it's taken 30 years for Voyager to get as far as it's gotten. So to go to another star system that has another planet is not possible. But until they actually have some kind of an understanding of these distances, and that's so hard to get them to understand. And when we come in, they're like, that was so cool. They begin to shift the way they think.
Yeah, and I actually do something similar, except I just use the Earth and the Moon, because we're a really big science center, but we're not big enough to walk out the solar system. So what we end up doing is we take a ping pong ball or some other baseball works, anything that's smaller, and we take a string, and the distance between the Earth and the Moon is about 30 Earth's diameter, or some 30 times the circumference of the Earth. So what we do is you wrap around a piece of string or ribbon or whatever you can find, and you wrap it around 30 times, and then you spread it out and see how far out they are. And they never guess how far it's going to be away. They usually guess like, oh, it's like this. And nope, nope, it's not like this. It's like, let's toss that across the science center. And that's about how far it is. So it's one of the activities that we do here to also talk about sort of size and scale. We do it on a, like I said, much smaller basis because we don't have the space to walk it out, but I've definitely done the walkout before as well.
But it's the same impact because it is that, oh my God moment of, are you serious? You know, and somehow they question you like, you gotta be wrong. And it's like, no, space is really big.
It's really big.
It's really big. And the misconception of, okay, my geekiness here, the original Star Wars with the Empire Strikes Back as they're going through the asteroid belt and up and over. And I'm like, that's not the way it is, guys. If it was, we would never be able to send any probes to the outside, you know, outer solar system. You could actually stand on an asteroid and you would not see anything else in the night sky. But the movies and Hollywood, there we go back to that perception of with computer graphics and what the kids see. And somehow, where do we find the science in it?
Yeah, and I think, so people are using a lot of like planetarium software these days. So I know Bob uses Space Engine. I use OpenSpace, which is a free software that you can actually use at home. But when you're flying around the solar system with those softwares, or you're flying around the universe with those softwares, what people don't know is you're actually flying logarithmically. So the closer you get to an object, the slower you go, and the further away from the object, the faster you go. And so we can move so quickly when we're doing those programs because we're moving logarithmically instead of linearly, because it would just take us forever to get to each of the planets, and our programs would be like years long, and we don't want to do that. So, you know, it's we definitely are perpetuating sort of that misconception, but also trying to let them know that, okay, this is logarithmic, and so we're not flying as fast as you think. We are flying much, much faster than you think we are, to get to the edge of the universe, because I couldn't get to the edge of the universe and back in 30 minutes. It wasn't for logarithmic flight.
No, it is. It's one of those, you know, I find a lot of when we discuss astronomy, and we're into astronomy, and it's, well, why don't we just? Okay, well, let's break this down and let's talk about this and what it means and how fast as humans, how fast can we travel and what does that mean? Bob does something for me. He's great about it. Is he has a virtual VR set. And so he's brought it into the schools, although it won't be this year, but last year, where the kids could put the headset on and he would take them to Saturn. And, you know, they're flying over, and to watch them and their reactions as they're going through the rings, as they're flying over Saturn, or they could choose to go to the center of the Milky Way galaxy. And as they're sitting there looking around them, and that is one of those, to me, the awe in their you know, their faces when it's like, I didn't know it was like that. And that's where you then say, well, you know, there's these free programs out there that will help you explore and see, which is great for education.
Yes.
Like you say, Space Engine, or the one you're using, or NASA Eyes on the Solar System, or, you know, in fact, one of Bob's favorite is Kerbal Space Program, which teaches the science of rocketry without the math, but you learn, you know, trajectories. You learn it just by feel and by doing it, because you don't have the math you need to do that rocketry yet, but you can do it and you learn as you go. So as parents out there are so many things that you can get. My first recommendation is buy your kids a telescope or a good pair of binoculars. Get them, and Orion has some absolutely fabulous, like tabletop that swivel that you can put in the trunk of the car or in the car and take it with you. And we gave both of our son-in-laws one, and that was the first telescope they had ever had. And both of them wound up camping, and other campers were coming in to look through the telescope, and you know, or a really good pair of binoculars that they can look at the night sky with. Build interest. These space programs, and most of these kids are so tech savvy, you know, half the time I look at my class saying, okay, I need help. Can somebody come and help me with my system? There's so many things that they then can learn about space, because there's so many free programs out there too. Not everybody can afford the programs, but there's so many free programs that will allow and I find in Space Engine, the kids love to build planets and smash them into each other, but it's cool to see what happens afterwards.
Oh, that's Universe Sandbox.
Or Universe Sandbox, oh, that's another one, Universe Sandbox. But to see what happens. So when you have a student that comes up, like last Christmas, I had a parent contact me saying, my daughter is hooked. We want to get her a telescope. What would you recommend? So they surprised her with a telescope for Christmas, and they talked to Bob and they talked to me about what would be a good telescope for her. And she is so excited about, she came in after Christmas and I got a telescope. And, you know, when you see that, you're thinking, that could be the next astrophysicist, or that could be the next astronaut walking on the moon, or that could be, you know, even if it's just that one child you touched, or maybe you've set something off in one of the kids at the science center that you've clicked something in them, and now they've become fascinated with it.
Yeah.
And they're going to take it and they're going to run with it.
Oh, absolutely.
One of the things that Connie really doesn't like is when her students say, I hate science, and that's because look at her.
Because science is everything. Science is absolutely everything. But more on what Connie was saying about softwares. So there's lots of free astronomy software out there, and some of it is super great. I know there's some really great apps that you can get if you want to go outside and try and find things up in the nighttime sky, because that can be tricky. Reading a star map, like kids don't know what a map is anymore. They know what they have Google. Like Google tells them where to go. So reading a star map can be really tricky. And so starting them off maybe with an app on the phone, and then being able to read a star map after that might be a great way to go. Stellarium is a wonderful software. Everything we use here at the Science Center to do our virtual programs is free. And we talk about our programs the program I use every time. So we've got Stellarium, we use NASA Eyes, so we use Eyes on the Solar System, Eyes on Exoplanets, Eyes on the Earth. We use all three of them for some of our programs, and you just download the one. And then there's OpenSpace that I mentioned before. It's actually a very data-driven software. So you fly around you can fly around the solar system and the universe. It's a little harder to use because it is a data-driven software. But it's still, like, if you've got someone in high school that's really interested in this, like, have them use that. That's actually legitimate software that people are using in their planetariums right now. So that's definitely something that could lead to a career, and you kind of have to get a little bit of coding in there to use the software. So It's definitely worth it. And then we also use another software called Worldwide Telescope. And Worldwide Telescope is fantastic if you want to see beautiful images of the nighttime sky. So if you want to see what Hubble saw, if you want to see what some of the X-ray or gamma ray telescopes are looking at, it has some objects in multiple different wavelengths of light, and is really great software to be able to look at objects and what pictures have been taken of them through that software. So I recommend all of those for sure. I haven't used Space Engine. It's on my list, but I think that's a pay software now. But
one of what you were saying with just even the software that they can get or the app they can get on their phone, you know, allowing them to go out and then hold their phone up and then find the constellation, or to find, you know, something that they want to see in the night sky. Is technology has truly brought astronomy down to the everyday man's hand.
Yeah.
And allows them to explore so much of, you know, the night sky, that is, instead of, like you say, trying to figure out how to use a star map, try to figure, and you're sitting there saying, oh my gosh, what, you know, and you don't want them to give up because they've gotten frustrated. So there are these programs and these apps for the phone where you can use it and look at the night sky, and you know, you plug in what you want and it'll show you where to turn. It'll show you where to turn, and then they can see it. If they're out a little farther. We live out a little farther, our school's out a little farther, so they can. In the city, you got to tell them, you got to get out beyond the lights.
You can see the Big Dipper. You can see the backwards question mark in Leo the Lion. You can see the really bright stuff in the city.
Yes.
Detroit isn't as bad as some major cities. I know when I was living in Chicago, like you couldn't see, you could see planets and like Sirius and that, or the Winter Circle, and that was it. But luckily here in Detroit, our light pollution isn't quite as bad as some of those really big cities. So you can see a little bit of stuff. But the really nice thing about those apps is they're actually using AR. So you're able to put it up to the sky and actually see what should be there.
Yes.
So if you can see a bright star, then you can point it there and find the constellation that's part of that bright star. Right. So I also find that if you know what you're looking for, you can see more. And like Connie said, looking up is so important. I know a lot of adults that, you know, we go out for dinner and it's already dark when we get out of dinner, and I'm looking, I immediately looking up.
And I look up.
And
then they keep walking.
Oh,
and you're like, but did you see Mars is right there?
There's Mars, there's Jupiter.
Mars over here, here. Yes.
And so, you know.
We tend to get into our lives that we tend to forget to look up.
Mm-hmm.
And most people don't realize you only see the one face of the moon. And it never occurred to them that they're always seeing the same side. And, you know, they're like, well, no, seriously, you're always, the light's different on it, but you're always seeing that one face. You never see the backside of the moon. And they haven't, because I think it's so much a part of their life, they don't think about it. And they don't realize it.
And there really is no dark side of the moon.
There is no dark side of the moon.
It's all dark.
Yes. So it's those things. There is a lot that adults can do. Astronomy is not just for school. Astronomy is for families.
Mm-hmm.
Astronomy is for, get yourself $100 telescope from Orion, a little tabletop that spins that you can take with you, or good pair of binoculars. Get one of those apps on your phone, take your kids outside, or just send your kids outside and ask them to look up, and take the time to look up.
And visit your local science center.
And absolutely. Especially when this whole COVID thing is over, because that's one of the places I do take my kids every year is down to the Science Center, because it's, you know, there's so much there to do.
So we've got about
phenomenal.
2 minutes left. We've had a couple comments in the YouTube channel here. Somebody posted there is a solar system walking path in Midland with proper distances, complete with model planets. Bicycles welcome. So that's pretty
Awesome.
cool. I posted a link to a NASA Walk the Solar System. I think it's the one you use. I posted links for Stellarium Worldwide Telescope and NASA EYES. Those are all fantastic apps. Does any of our viewers have any questions before we go?
Well, hopefully we've given them some things to think about and some things that they can start with their kids, and maybe different ways of looking at things
And
with their own kids.
and the sooner you start, the better.
Oh,
And you know, but also if they're not interested in the science, there's still hope. There is still hope. But the thing about young kids and our younger audiences is that that scientific curiosity, you are born with scientific curiosity. That is how you learn how the world works. That's how we learn language. That's how we learn how to walk and talk. It's scientific curiosity. And so continuing to encourage that scientific curiosity from a young age is fantastic. Or be goofy and include scientific curiosity once they're older, if they've lost that imagination and curiosity.
Teach them to get it back, and teach them it's okay.
Yeah. Always
okay. Thank you very much, Paulette Epstein, Connie Trembley. For our viewers, our keynote speakers, Brother Guy and Dan Davis, are starting right now, so hop on over there. We have a bunch of other good programming tonight. Enjoy the evening. Good night, all. Let's see, how do we cancel this?
We usually end.
I don't have that option. Everybody just leave. Yeah.
Go to the next one.
Bye all.
Bye, Paulette. It was wonderful.
Yes. Absolutely.
I hope to get my kids down to see you.
I hope so too.
Oh, it's amazing down there.
The IMAX has reopened.